Let's begin our journey into cloud computing here and just understand cloud concepts in general before we get deeper into the subject. And let's begin with just talking about how we got here. And ultimately, we've been on this journey, this wave over the past few years from traditional data center, that's probably built on top of VMware, where you had an ESXi host. So instead of all these physical machines, I personally went through this myself, where we were shifting physical machines into virtual machines. Instead of hundreds and hundreds of servers in the data center, we would build these VMware hosts and then basically virtualize our operating systems and put them on top of VMware running on a physical machine. And so that traditional data center, gave the rise to virtualization, and now that's ultimately given the rise to cloud computing, whether that's Azure, whether that's Google Cloud Platform, whether that's AWS. We saw the rise of AWS first, we quickly saw Azure come behind, and even rapidly now in the past few years, we've seen GCP really accelerate. And so it's really exciting that all these cloud providers are out there and the competition is so fierce and creating all these rich services. And, it's very interesting. Google came to the game late, but look how much they've invested. Look how fast they've caught up in core areas, and look how they differentiate, particularly in their data services as well. But let's discuss cloud computing again in a little bit more detail as a whole. What does it really mean? What is cloud computing? We know people are moving from the data center to cloud. We know people are building applications in the cloud using modern architectures. But what is the heart of all of it? Well, we divide it up into 5 major areas. Number 1, it allows on-demand self-service. So no human intervention needed to get resources. Now, there are occasions, obviously, with the services that you choose to consume from the cloud that you're going to need people to help admin cloud computing. You wouldn't be taking this Google course if you didn't need to admin that in your environment or realize there's a demand to administer that. But the concept here is that, hey, if I want to get something that Google offers, I can go to the portal, I can go to the command line, I can go to an API. It's on-demand self-service. Nobody needs to go and rack a server. I've got all these CPUs, memory, and disk, all available on-demand self-service. Broad network access is another key thing. I can access from anywhere. With public cloud services, everything is accessible via the internet if I want to allow it to be. So there's obviously restrictions you put on networking. It's not like everything's just wide open, but my ability to get access to the public cloud is there. I can access my Google console from a mobile app now. I can access it from my laptop through a web console. There's lots and lots of options there, and then I can start to connect these networks. I can create private networks inside of my public cloud provider. I can connect those networks inside of GCP, say back to my on-premises data center. Lots and lots of options there from a network perspective. Number 3, we have resource pooling. So provider shares resources to customers. So that is the core of everything here. Just think of the economies of scale that you'll hear more about is, Google, Microsoft, Amazon are all doing this. They're buying lots and lots of hardware, putting it in these giant data centers. They're really good at managing these data centers, the power, the cooling, all the redundancy and everything there. And then they can share these resources out to you. So you only need to pay for what you need. Think of it like an energy utility. It's not like everybody now has their own wind turbine or, in some cases we have solar cells and things on our houses, but for the most part, people do get their energy from the grid. And that's because we go to a central power plant and it distributes that out to us. The same concept, can be thought about with cloud computing is I'm going to a central provider, I'm getting my CPU, my memory disk. Utility concept there is what we're going for. Rapid elasticity. Now this is really key as well because I can get more resources quickly as needed. I want more CPU, I can get it. I want the latest Intel CPU. Google's probably already put it in their data center and I can use the next generation of virtual machine. I can also start to do cool things like auto scaling where perhaps a virtual machine hits a certain CPU threshold, another one spins up next to it, joins the load balancer, and the web traffic is now split across those virtual machines, and my workload can respond to seasonal demand. Think of it like a retail store that has to respond to lots and lots of transactions on Black Friday as a good example. and then measured service, pay only for what you consume. But the transparency here is key as well. Cost transparency, knowing what everything costs. It's a big black hole for a lot of people in the data center world. While there are certainly some cost benefits sometimes in buying, physical hardware and racking it in a data center and sort of committing to that spend, and there are measures in the public cloud, you can do that now as well. But when we go to public cloud, we've got a pricing calculator, we've got cost transparency, we know what we're consuming, we get the bill, everything we use, everything we consume is measured. So if we break it down a little bit further, cloud computing is about renting resources versus purchasing hardware. You pay for what you use. You run your applications in someone else's data centers. Just remember, there's still a data center somewhere. There are CPUs, memory, and disks all racked in servers in another data center. Your applications are running in that data center. You're going to choose the region and the zone that you want to put those resources in, but they're ultimately running there on some hardware for you. The cloud provider is responsible for the physical hardware and facilities necessary to execute your work. So you're handing over that responsibility. There is a shared responsibility model that you'll hear every cloud provider talk about, because they're saying, hey, I'm going to take on up to this level, then it's over to you. So a virtual machine is a great example. Hey, they're taking care of the power, the cooling, the CPU, memory disk, the racking, stacking of that hardware. They may even provide an image for you for the operating system, but you then need to keep it maintained, patched. You're going to install your software on there. That's ultimately up to you, and that's your responsibility, but they're going to take everything else on for you that's below that layer. The cloud provider is responsible for keeping the service they provide up to date, and that goes back into that previous bullet. What they provide, they are responsible for, and you have to keep an eye on this because they do retire services if they're not going to get consumed a lot. We've seen Amazon do that a lot. They've brought out services and retired them later on. So just keep that in mind as well. They're responsible for keeping the services they provide up to date. They can also choose to no longer provide a service over time as well. So that's your quick primer in cloud concepts. Definitely know those 5 major areas, and next we'll go on to cloud economics.